So before we go over how to do the ice cream sales problem in Desmos, I want to talk about the last video that you just watched. So that video was on Desmos and how to find the regression line and correlation coefficient. So those instructions were to type or copy the data into a table. And then once you've done that, in the next line in Desmos, you're going to enter Y1. Then we have this little squiggle here called a tilde, and that's typically located in the top left corner of your keyboard. And then we'll put M and an X1 plus B. Okay, and then from there, Desmos will tell us the correlation coefficient, the slope, and the intercept. We'll be using Desmos in this class. You're certainly welcome to use Excel, Google Sheets, graphic calculator. There's a lot of different ways of finding these values. I just think Desmos is probably the best one for this particular class, so that's what we're going to use. All right, so in order to put this into Desmos, we do need to go get our data. And rather than typing it in, I did put it all in a spreadsheet in Excel for you. So right below where you downloaded the guided notes, if you're on the chapter 1.6 lecture page, you'll see a link for the 1.6 data sets. It's also in the same folder that has all the guided notes and homework. So if you're looking for it there, you should be able to find it as well. Okay, so once you've downloaded that, we're going to need to go and find the data set we're interested in and highlight and copy that. So give me a second. I'm going to switch screens so we can look at Excel. Okay, so here are our 1.6 data sets in Excel. And you'll notice that there are 3 data sets across the top of this page, the ice cream, GPA, and commutes. One thing, we're going to do all 3 of these in the notes, but one thing I want you to notice is if you go down to the bottom, there are these tabs, and so it says notes, which is the ones we're going to use in the lecture. Homework 1.6, this is actually going to be A and B both, so both of those homeworks, the sets are there. And that's going to look like this. So this one's A, the other 3 are B. It'll be really obvious once you're looking at the homework which data sets to use. And then I also have the one for exam 1 in here as well, the take-home part of the exam. So all of your data sets are here. Don't lose track of this file, or just make sure you can re-download it. And we want the ones for the ice cream sales. So I'm going to highlight just these numbers, the temp and the sales, and then I'm going to copy those. And then I'm going to switch over to Desmos. So give me a second while I switch screens again. Okay, so here we are in Desmos, and I'll put a link for this in Canvas for you. So this first line here, I copied that data. I'm going to paste it in. So there's my X and my Y column, and you'll notice it automatically plotted those for us. So that looks a lot like the picture that we have on our paper. It's scaled a little bit differently, so it looks a little steeper, but this is what we're looking for. And then what we need to type is Y1, and then the tilde, MX1 plus B. Looks like that. So that looks like a nice fitting line through those points. And so we get a correlation coefficient over here on the left. So right below where we typed Y1, MX1 plus B, we see that R is equal to 0.9575. So that gives us our correlation coefficient. And then we have a slope of about 30. And an intercept of -159, and then I rounded this to 0.5. Okay, and that is going to match exactly what we have in our notes. So let's take a look at that. All right, so here are our notes. I went ahead and put down our correlation coefficient, 0.9575. Okay, and so we did say that we expected this to be positive when we were first looking at our graph, so that's a match. And then we said that this would be strong. And remember that a strong relationship is going to be on the positive side, will be as R gets closer and closer to +1. This is getting awfully close to +1, so that kind of matches what our intuition told us. And then in terms of our equation, we have Y equals 30x. So that was the slope. Our slope on Desmos was 30.08. So I rounded that to 30. And then our intercept was -159.5, which is what we have here. So that is a matchup. Let's go ahead and take a look at the one at the top of the next page. All right, so this problem is about college admissions. And this is actually really interesting. So they are plotting students' high school GPA, so their average of their 4 years in high school, versus their college freshman GPA to see if there's a relationship there, right? So a lot of times when you apply to colleges, they look at things like SAT scores, extracurricular activities, and GPAs. So we're going to see if there actually is a reasonable relationship there. We're going to start by plotting the data and looking to decide if it's linear. So remember that everything we're doing in this section, it only works if we're looking at data that's linear. So we're going to start there. We'll go to Excel and copy that data set. All right, so here we are back in Excel. We're still on the Notes tab, and here's the GPA for high school and college. So I'm going to highlight those and copy those. And then I'm going to pop over to Desmos, and we'll paste those in there. All right, so here we are back in Desmos. I'm going to copy those in. Let's see what we get here. Oh, they're way down here where I'm not able to see them very well. So let me expand this out a little bit so we can actually see what we have going on. All right, so that's a lot better. That's a lot easier to see. And it should make sense why we have to zoom in so much because GPAs are from 0 to 4, right? And so high school ones go further, college ones only go 0 to 4. So there isn't going to be a whole lot of spread in that data. So zooming in here makes a lot of sense. And then let's go ahead and get our correlation coefficient. So when I'm looking at this does look linear. So I would say that a linear fit does seem appropriate. It does seem to make a fairly straight line. And let's see what we get for a correlation. So our R value here is 0.8318. And I do usually write 4 decimal places down for the correlation coefficient. For the equation, I try and go 1 or 2 decimal places further than what's actually in the data. So here our slope is 1.17612. It's a lot of decimal places. So I think I'll probably use 3 decimal places on this one since my original data came with 1. So 2 or 3 would be good here. To get y is equal to 1.176. And then my intercept, I'll do 3 decimal places again. So notice that that intercept comes with a minus sign. So we're actually going to put that minus sign down, and then I get 0.86. But you could use an 8 or a 9 here. I'm fine with kind of however that rounding goes in terms of getting an answer there.